Welcome to another segment of High School Geometry with Netz and Weichel. This is Mrs. Netz.
And this is Mrs. Weichel.
And today we are going to be talking about 2.5 composite transformations. What we are learning, well, by the end of this lesson, I will be able to experiment with and explain transformations on the coordinate plane, showing my knowledge of spatial understanding. Why do we need to learn this? So we can understand we are surrounded by space and the shape of things that are moving or being transformed. How you will know you know it is you will know you have mastered it when you are able to describe a series of transformations between an image and its pre-image.
Okay, let's go ahead and get started. A composite transformation is going to be a series of transformations containing two or more transformations in one graph. So we are going to be doing translations, reflections, and rotations all within one problem. What is different about this than what we did in the previous three lessons is you are only going to use the initial preimage the first time, and then the next transformation will use the last shape you had, kind of like touch and go.
You can almost think of a series of transformations like walking. You're always going to take the next step from the previous step.
And then I have an example here. You don't need to draw it. I just wanted you to see it as it is completed. The pre-image is triangle 1, which was reflected over the line y equals x to shape 2. Then triangle 2 was translated up to triangle 3. That's going to be what you're going to be doing today with composite transformations.
Okay.
So let's go ahead and do one. How do you know when to do it? The first way is if you're flat out told how to do it. In this case, you're going to take triangle ABC and you're going to reflect it over the line of y equals x, and then take that image and rotate it 90 degrees about the origin. So the first thing I need you to do is pause the video and graph triangle ABC. The coordinates are in the lower left side of your screen. Okay, so now we're going to take triangle ABC and we're going to reflect it over the line y equals x. Remember, the line y equals x is going to be, it's going to be going right through the origin with a slope of 1 over 1. So it's going to be this diagonal line going right diagonally through the center of the coordinate plane that you are given.
So remember, that line y equals x is where every single point that you graph, your y value is equal to your x value.
Which is why the rule, if you remember back a few lessons, for this particular lesson is going to be yx. So you can either count your diagonals or you can go ahead and apply the rule, but why don't you go ahead and pause your video and see if you can reflect triangle ABC over the line y equals x. Okay, so our first one we have is negative 2, 10. If you use the rule, you should have went over to 10, negative 2 and graphed your triangle. And you can see that the other 2 points are where they should be. If B is at negative 9, 9 to start, then reflecting it would put it at 9, negative 9. C is at negative 3, 4, so reflecting it over this line would put it at 4, negative 3. Now you're going to take A prime, B prime, C prime, and you are going to rotate it about the origin 90 degrees. Go ahead and do this so you can see the colors. Sorry. All right, so we're going to rotate 90 degrees. Remember when we went over this in the last lesson, rotating 90 degrees. Each time you go 90 degrees, your x and y just switch places. If I'm currently in quadrant 4, going 90 degrees would put me in quadrant 1. So we are going to go ahead and take this A point, which is at 10, negative 2. We're going to switch the 10 and 2, and it becomes a positive 2, positive 10. Same with your B and C. If B is at 9, 9, rotating it will still be at a 9, 9, but in quadrant 1. For C prime, you're at a 4, 3 point, so flip them, you get a 3, 4 point, but in quadrant 1, so they are both positive. Notice that A prime became a double prime. That is because this was our pre-image for the second transformation. So if this is my pre-image, it became a double prime because we moved A prime. So if you need to pause this and watch this problem again, please go ahead and do so. If not, we're moving on. Okay, so the next one, all you guys that love the algebra, you can actually always make a rule. The rule is like your input-output, if you remember. So if you would pause the video first, go ahead and graph DEF. And then we're going to just plug each point into the rule and get our new output. Okay, so you should have graphed the triangle where we have it. If I was going to take this triangle and plug in point D into the rule, you can see that D has a y value of -1, so it's going to become a -1, and then I'm going to add 1 to it. That's going to give me my new x coordinate. Then after, you have an x plus 3 for your rule. Well, my x is -5, so I would plug in -5 and add 3 to it. -1 becomes 1. 1 plus 1 is 2. And then -5 plus 3 is -2. So if I were to take D, plug it into this rule, my output becomes 2, -2. So 2, -2. 2, -2. I went to the wrong place. There we go. So using just the rule, it's going to be a single transformation. The composite piece is all rolled into one. However, there are actually a couple different transformations taking place here. So if you were ever asked to describe the transformations,
it's actually really easy to do if you remember all your rules. So you'll remember that anytime we added or subtracted to an x or a y value, that was always a translation, and you can still use that.
So if you were to take your, I'll just make this a little lighter. If you were to take the +1, +3 out of it, we know that that is a translation. Look at what's left. Just a -y, x.
So now we have to kind of ask ourselves, what was that rule?
Well, if you look back in your notes, there were basically two lessons where we had rules that looked like this. And the -yx was a rotation of 90 degrees counterclockwise about the origin. So if I were to apply that single rule to DEF, so D right now is at -5, -1. If I rotated it 90 degrees, so quadrant 3 would become quadrant 4, and it would become a 1, 5 point. So 1, down 1, 2, 3, 4, and 5. And it puts me right here. Then D would then translate right 1 up 3, and you can see if I go right 1 up 3, that's right where my D prime point is. So when you have a composite rule, you can just go straight to the final image. However, please keep in mind that this composite rule actually represents a rotation of DEF to this pink triangle, and then a translation of right 1 up 3. I would definitely add into your notes somewhere off to the left or above, whenever asked to describe a composite transformation, adding or subtracting a number will 100% always be a translation. The negatives and where the x and the y are, that's all going to stem back to reflections or rotations. So it's important you know those 7 rules we went over with reflections and rotations. All right, next is if you're given notation. The hint that I need you to write down for this is going to be that you are going to read this right to left. It always starts at the right side, which is, I know, a little confusing. All right.
Well, so if you think about the coordinate plane is backwards because it goes counterclockwise when we number our quadrants 1, 2, 3, and 4.
So think of it that way.
Transformations, they're going to go backwards from what we're used to as well. So you're going to read from right to left when you're following your rules.
So the very first thing you have to remember, your notation form, a capital T is going to represent a translation, and then the -5, -1 is telling us to translate triangle GHI left 5, down 1. If you haven't done this yet, please pause the video so that you can go ahead and graph the triangle. Your coordinates are on the lower left side, and then you can actually translate it left 5, down 1. Okay, so you should have triangle GHI graphed by now. You should have counted left 1, 2, 3, 4, 5, down 1, giving you triangle G prime, H prime, I prime, located right there, right on the edge of quadrant 1. Your next transformation is going to be a rotation of 180 degrees. So you can either do this right on the graph, or you can apply your rule. If you remember your rule for rotating 180 degrees, it is negative x, negative y, because you're going to 90 degrees, your xy switch back to xy. You just have to change both sides. So, I'm sorry, signs. So for this, you can see that H is the easiest to see right off the bat, is at 1, 2, 3, 4, 0, 5. So if I switch the sign, 0 would stay 0, but 5 would become a negative 5. And then G and I prime are in quadrant 1, so rotating 180 would go, here's 90, 180. So it's just going to be the same x and y coordinates as J prime, I prime. But you're going to be down here in quadrant 3. So 1, 2, 3, 5. So we're going to be right down here. That is not what I wanted to see. All right. There it is. Okay, and the last thing we're going to do is we are going to reflect over the line x equals 0. Remember, reflecting over x equals 0 is where is x always equal to 0? What line is x always going to be 0? And it is going to be that y-axis. So h double prime is already on the y-axis, so it's actually going to stay right there. G double prime is down here in quadrant 3. It's 3 away from the line of reflection, so we're going to end up 3 to the right of that line of reflection, giving me my final resting place for my triangle right there in quadrant 4. Notice that I once again added a prime notation. So G up here in quadrant 1 moved left 5 down 1 here. So the image of G is right here with G prime. Then G prime rotated to here. So G prime, the pre-image, became G double prime for the image. And then G double prime is the pre-image reflected over the y-axis, becoming G triple prime. Anything else?
I think that's it on that one.
Right. And then the last problem we are going to look at is going to be giving a rule. So remember, we talked about the rules, composite transformations. When you have a rule, you can just input into the rule and get your final output. I'm going to go ahead and ask you to split it up. So you can see here that once again you have this translation part, and if you look at what is left other than that translation, you have x negative y. So if you need to look back in your notes, what is that rule discussing? It's discussing a reflecting over a y equals 0. So we're going to reflect triangle ABC over the line y equals 0. And then you're going to translate it up 4. So go ahead and pause the video, graph triangle ABC, then reflect it over the line y equals 0, and then translate that image up 4. Okay, so your pre-image should be located where mine is. You should have then reflected it over the line y equals 0, which is the x-axis. That is where y is always 0, giving you this image. And then you should have taken that image and translated it up 4, giving you A double prime, C double prime, and B double prime located where I have it. If you need to pause the video to get that, please go ahead and do so. So the reason this is a special rule, while it is a composite rule, it is describing reflecting over the y equals 0 line, translating up 4. If I were to go back here and just show you this.
Wait a minute. Isn't that just like a reflection over a different line? Maybe like, I don't know, y equals, it looks like 1? No, 2.
You are correct. So this line is just reflecting over the line y equals 2. So this is a special rule in that it describes a composite transformation, but it's describing a single reflection. So I know I love this little trick.
So does it matter which way you do it, if you do it in 2 steps or in 1?
It does not matter. Just know that if you're given an x negative y, that is a reflection. If you're given a negative x, y, that is a reflection. Then the number, so there's the reflection. Then the number divided by 2. So the number divided by 2 gives you the line of reflection. So in this case, oops, I can't spell reflection. So in this case, what is 4 divided by 2? It's 2. And then what is the negative? So then remember, x negative y is reflecting over y equals 0. So this is y equals 2. So there's your little
Very
trick.
Cool. So how do we do this every time then? And how do we recognize when to use a special trick?
So again, when you can recognize that the part of the composite transformation is a reflection. So right there, I know that that is a reflection over x equals 0. Because negative xy is the rule we taught you in lesson 2.3. Now, the number, if I divide it by 2, it actually becomes a reflection of x equals 3. That's the line you can actually reflect over in one step. It goes, you can write a rule the other way as well. So if I say reflect over, if I say reflect over the line y equals negative 5, well, I know my rule then needs to show reflecting over y, because the line is y, so we make the y negative. And then instead of dividing by 2, since we're now putting it back into the rule, you would times it by 2. So if I times this by 2, I actually get an equation of y and then minus 10. There's my rule. Or if I say reflect over y equals 4, well, x has to become negative because that would be like reflecting over x equals 0. And then double the number because I'm putting it back in the rule. That's a positive 8. There's my rule.
Very cool.
So that is the conclusion of actually this unit. Hopefully you guys feel like you can perform sequences of transformations and of course, as always, describe the sequence of transformations given a rule. You will be asked to, given a composite rule, what is the what transformations are taking place. So it is important that you are able to dissect a rule and describe everything that is taking place. As always, if you have questions, please message us on Remind or email us at our emails or contact your teacher if it is not one of us.
Hey, Mrs. Weichel.
Hey, what, Miss Nets?
What do you call a teapot of boiling water on the top of Mount Everest?
What?
A high pot in use.
Like a triangle. That's so funny. Thanks for joining us.
See you next in chapter
3.